Learning objective and key concepts. The learning objective for this module is recognize the impact that malicious exploits and attacks have on network security. Key concepts: hackers and their motivations, the hacking process, hardware failures, physical threats, accidents, and other disasters, common types of malware, social engineering practices and their impact on network security efforts. Hackers and their motivation. Why do they do it? They do it for the thrill, social validation, as a hobby, street creds, as a challenge, maybe peer pressure, status, money, attack perceived social injustice, power, or financial gain. Primary types of hackers are recreational, enjoy learning and exploring, especially with computing technology. Opportunistic, timid, not likely to initiate an attack but will take advantage if the right opportunity presents itself. A professional, criminals whose sole career objective is to compromise IT infrastructure. Some favorite targets of hackers: easy assets, that's hardware. Those that pay off quickly, monetary or barter gain, funds, cryptocurrency, credit cards, bank accounts, control of networks. Unique targets, they can be challenging, complex infrastructures. Easy targets, IT infrastructures and elements not properly secured. Threats from inside the network and outside the network. On-site employees, they have physical access to the facility. They have logical access to the network. And in your security policy, you need to address threats in your security policy, network design, infrastructure deployment, and ongoing system and security management. Common threats to the network security. Insider threats is probably the largest threat to your network. You have disgruntled employees who believe they have been wronged by the organization, and can include contract workers and people that just misconfigure something and don't pay attention to the security. External threats are hackers. Let's identify the 5 phases of hacking. Typically, these steps are reconnaissance, scanning, enumeration, attacking, and then can be lateral fallback attacks or post-attack activities. Reconnaissance is the first step. It's the act of inspecting and exploring the network, also called footprinting, discovery, research, and information gathering. And that's usually through like pen test tools. Wireshark could be part of that probe also. Here's some examples of reconnaissance: examining search engine contents, reviewing the organization's website, investigating the background of personnel, performing location mapping, auditing financial records or reviewing public filings, reviewing court cases and other public records, querying WHOIS domain registrations and public IP assignments, eavesdropping on email and other conversations, visiting a physical location for the organization. Scanning is the activity of using various tools to confirm information learned during a reconnaissance and to discover new details. Aimed at discovering live and active systems, can include war dialing, war driving, ping sweeps, port scanning. Often referred to as probing, the hacker sends packets to elicit responses and is detectable. Basic TCP and UDP port scanning. In these examples here, we'll look. The first set is a TCP scan. Remember, TCP is a connection-oriented protocol. So the laptop on the left is going to scan the server on the right. And that first scan, he's going to, on a certain port, is going to do a send request. If that port's open, the server is going to send back a SYN ACK. The laptop's going to acknowledge that with an ACK packet, and that port is open, and a conversation could happen. The next example is the laptop wants to send a scan on a different port. He sends out a send request packet, and the server does not have that port open, so it's going to send back a reset response packet, meaning this port is closed, it's not listening, and it'll say reset by server. The next example is the desktop on the left wants to talk to the server on the right and is going to do a UDP scan. A UDP is, remember, is connectionless, so there is no guarantee, there's no three-way handshake. It's going to send the datagram, and if it gets there, and we presume it's open because we're not getting a reset. So the next scan, the bottom one, the desktop on the left, sends a datagram, and there's several reasons. It sends back an ICMP type 3 response back, and there's about a handful of reasons why it would send an ICMP response back, a type 3 response back. It could be the network's not reachable, the host not reachable, the protocol's unreachable, a port is unreachable, there's fragmentation, the source route failed, a destination network is unknown, a destination host is unknown, the source host is isolated, and a couple other reasons. Enumeration, the discovery and listing of potential attack targets. Hackers' process of discovering sufficient details about a target to learn if a vulnerability exists that they can successfully attack. They probe open and closed ports of a target. Open ports have services that run behind them. And banner grabbing is probing services to obtain information about a host. A banner grabbed from a web server. In this example, we'll see a ZenMap discovery for whitehouse.gov as the target there. And you'll see the script. It starts at 3/25/2020 at 11:43 Central Daylight Time. The host is scanned as up. Other addresses for whitehouse.gov is the IPv6 address there, 2600. The DNS record is for 184.29.151.222. And we see that ports 80 and 443 are open. And if we get down there to the bottom IP address, there's one host that is up, and the scan took 41.58 seconds. Attacking. It's the briefest phase of the hacking process. If it's a successful attack, it may only take seconds. Then you move to the post-attack activities. If it's a failed attack, modify the approach and relaunch the attack. Return back up to the enumeration and look for results to select a new point of assault, and then move to fallback attacks. Post-attack activities. Once the attack is successful, then they'll try privilege escalation. They might deposit additional hacker tools, pilfer some data, or also create a re-entry point, or commonly referred to as a backdoor, and then they'll want to cover their tracks by removing any evidence of the hack. These are some common IT infrastructure attacks: hardware failures and other physical threats, natural disasters, and accidents. Hardware failures and other physical threats. Hard drives and hardware failures are the most common cause of downtime. Preparation is the best defense. Perform consistent periodic backups. Conduct general cleaning and maintenance. Keep spare parts on hand. Replace equipment before it fails. Solid state drives, SSDs, eliminate many problems associated with hard disk drives, but at a greater initial cost for the hardware. Hardware failures and other physical threats can also be too much heat, moisture, static electricity discharge, intentional electromagnetic interference, frayed wires, and theft. Natural disasters are another threat. Weather events. Understand the types of weather events common in your area. Precautions. Special insurance might be needed. Structural reinforcements, lightning protection, surge protectors, bilge pumps. The best protection, a reliable, regular backup stored in a secured off-site facility. Accidents are a threat. Spilling liquids on equipment, tripping over cables, pulling out the wrong power cord or cable, tripping the building circuit breaker, setting off the water sprinklers, knocking over a computer, turning off a system prematurely, installing the wrong driver. Precautions and protections, backups, configuration documentation, and training. Adjustments to worker activities, training employees what to do in the event of an accident or emergency. Malicious code, or malware as we commonly refer. Some of the distribution methods are software downloads, email, malicious websites, file transfer, flaws in software. The effects of malware on a system could be data loss, exposure or change, poor system performance, pop-up ads, system becomes a bot or a zombie on the network. Common types of malware: viruses and worms, Trojan horses, keystroke loggers, spyware and adware, rootkits, logic bombs, trapdoors and backdoors, dialers, URL injectors, exploits, and mobile code. APT, or Advanced Persistent Threats, are highly targeting intelligence often gleaned from other types of attacks, such as phishing or social engineering. Occurrence has increased dramatically but represents a small percentage of attacks. Fast growth and overuse. A slightly slower growth rate to build network security concurrently with expansion of the organization is more likely to provide sustained growth and longevity. The negative side of that is failure to address security issues in a period of explosive growth is more likely to result in catastrophic failure. In this example, wireless versus wired, the attacks on wired networks require local attacks. Wireless networks allow for remote attacks. Eavesdropping is the act of listening in on communications. Recording of a network traffic using a packet capturing tool like Wireshark, or is commonly referred to generically as a sniffer. And they may eavesdrop against data packets or against voice traffic. Can occur over both wired and wireless connections. Prevent eavesdropping by using cryptic protocols. Eavesdropping on an existing session between a client and a server, the attacker merely has to be on the switch where some of that communication is happening, can then run Wireshark to capture the traffic and then replay it. Hijack and replay attacks. Hijack attacks occur when a hacker uses a network sniffer to watch communication sessions to learn its parameters. The hacker disconnects one of the session's hosts, impersonates the offline system, and injects crafted packets into the communication stream. The hacker then takes over the session of the offline host. Replay attacks, also known as playback attacks, the hacker uses a network sniffer to capture network traffic. The hacker retransmits that traffic back onto the network at a later time. The goal is to gain interactive sessions across the system. Here's a diagram of how a replay attack collects authentication packets and then retransmit the packets at a later time. Insertion attacks, and these are probably more ones you probably are familiar with and have heard a lot about, but SQL injection attacks, IDS insertion, cross-site scripting, and rogue device insertion. Fragmentation attacks abuse the fragmentation offset feature in the IP packet. They occur when many different network links connect to construct a global infrastructure. Overlapping can cause full or partial overwriting of datagram components, creating new datagrams out of parts of previous datagrams. overrun can result in excessively large datagrams. Other fragmentation attacks cause denial of service, DOS, or confuse intrusion detection system detection and firewall filtering. Buffer overflows. The buffer, an area of memory designated to receive input. Buffer overflow, an attack against poor programming techniques and lack of quality control. These attacks are memory-based attacks, typically a result of poor programming, can result in code injection and used for crashing systems. Session hijacking, spoofing, and man-in-the-middle attacks. These attacks on systems and networks can involve falsification of credentials or misrepresentation, posing as another entity, sending messages that the system is a different machine. Session hijacking. The hacker takes over the connection after a client authenticates with a server. An attacker does not directly learn the credentials from the client. Many deploy these techniques: DNS spoofing, poisoning, ARP spoofing, ICMP redirects, and rogue DHCP to alter the route or path of a session. Hosts that use TCP/IP without encryption are vulnerable to session hijacking. Encryption equals only true protection against session hijacking. Session hijacking steals a connection from a client. In the top, we see the hacker merely is a man in the middle. He grabs the connection and then stops the communication with the client and poses as the client talking back to the server to hijack the session. Spoofing attacks involve falsification of information, falsification of the identity of a source, is email addresses, MAC addresses, and IP addresses. Hacker impersonates an authorized entity. They're difficult to prevent and hard to detect. To detect a spoofing attack, watch normal traffic and look for addressing anomalies. Spoofing of a client's MAC address by a hacker's computer. In this example, we see the victim's MAC address ending in BB15 is the real MAC address. The hacker knows that MAC address, and the hacker system, it ends in 17C8, manually configures his MAC address to that of the victim and now appears on the network as the victim. Man-in-the-middle attacks. ARP spoofing. ARP is Address Resolution Protocol. It's a non-authenticating broadcast query service that requests the MAC address from a system using a specific IP. MAC spoofing. The hacker's computer uses the server's MAC address to receive traffic instead of the intended server once the server is flooded. DNS poisoning. The hacker compromises a DNS server and plants false FQDN to IP mapping records. The DNS source then feeds subsequent user queries false data. DNS spoofing. A non-authenticating query service requests the resolution of a FQDN into the related IP address, allowing false DNS response to be sent. ICMP redirect causes a host to alter its routing table. Proxy manipulation. The hacker reconfigures a client's proxy configuration. Rogue DHCP. A false DHCP server that can provide IP address configuration leases for a unique subnet and define the default gateway because the hacker's computer acts as a man-in-the-middle router proxy. Rogue access point. The hacker configures a rogue wireless access point similar to the real authorized access point that can fool users into connecting, which then serves as a man-in-the-middle proxy. Man-in-the-middle attacks fool clients into initiating sessions with the hacker instead of the target server. Covert channels. They are hidden, unknown, unique, atypical pathway of information transfer. Timing channel conveys information through timed and synchronized activities. An example of that would be Morse code. Storage channels convey information through unseen or undiscovered locations. An example of that is slack space or flash memory. Slack space is the unused portion of the last cluster only partially consumed by a stored file. So each one of those clusters is 512 bytes, and you have a Word document that doesn't take up a full cluster. That is called slack space. That's the unused portion in the cluster. Network and resource availability threats. Many attacks require special access on a private network. Availability attacks are a fallback option when hackers can't locate a vulnerability to exploit. Examples of availability attacks is a denial of service, which prevents legitimate access or use of a resource to delay or interrupt business. Can involve exploitation or a flaw or traffic generation. Distributed denial of service attacks through massive distributed processing and sourcing. The foundations are agents, bots, zombies, which are malicious code implanted on a victim's systems across the internet. A denial of service is flooding attack against a client. And as we discovered earlier, TCP is a three-way handshake. So what happens here is we have a lot of requests going from the hacker to the victim, and they remain open. It never completes the three-way handshake. So the victim has to keep that connection open and listen. So basically the hacker is sending hello, the victim is answering, hello, I'm here, and there's nothing to follow up to complete that three-way handshake. So the hacker sends another hello, and it has to keep that first connection open because it's waiting on a response. The second hello it receives, it says, hello, I am, and the attacker never responds, so he sends another hello, and it just keeps flooding that system, and all these open connections basically is denial of service that keeps the victim busy and cannot respond to legitimate traffic. Distributed denial of service flooding attack against a primary target. It's the same concept of the first one. The attacker sends the victim a hello for the three-way handshake and never follows up with another response. The only difference here is they use the systems across many different, could be in a same network or from outside the network coming in, and it's not just one attacker, it's multiple attackers, and with all these attackers asking for these hellos and never getting a response, that's how it's distributed. Hacker tools. Any software can be used as a hacking tool. Operating system utilities, commercial applications, custom code, and more. Whitelisting is the best defense. Whitelisting restrictions. A whitelisting system incorporates a list of approved software executables for use. Applications not in the list are blocked. Social engineering. The art of manipulating and exploiting human nature to get people to perform tasks or release information that violates security. Humans are the primary target. People are the weakest link and can be tricked or fooled. Techniques include impersonating a position of authority, asking for favors, offering social validation, or creating urgency. Gaining access to inside information is often the first element of a social engineering attack. Other techniques include dumpster diving, reconnaissance, and cold calling. The best defense is user training and security awareness. In summary, we've learned hackers and their motivations, the hacking process, hardware failures, physical threats, accidents, and disasters, common types of malware, social engineering practices, and their impact on the network security efforts.